Hello, I would like to welcome you in this session on probability. So before we discuss in detail what the probability is, let me tell you what exactly we are going to cover in this particular session. So we will see the different ways of assigning probability. We will try to understand what are different types of probability like marginal, union, joint and conditional probability. Then we will see that what are different laws of probability which we need to use to solve problem related to probabilities. And then we will see in some cases when we have to revise the probability. So how do we do that? So first of all, let's start with the probability. You must have used this word frequently. You must have studied this particular thing somewhere at your school level. So probability is nothing but just happening of something. Here the difference is now we would like to assign some number to it. Now how to assign that number? We have different methods. For example, if somebody asks you that will it rain today? So what would be your answer? Or if you say that yeah, there are chances that it will rain today. Or you can say the maximum chances will rain today. Or you can provide some number that this much percent of chances of rain today. So how to find out that number? There are certain methods. So we will talk about those methods. So first of all, it comes classical method of assigning probability. Then we will see what is the relative frequency of occurrences. And then we have subjective probability. What the classical method says, if you have conducted some experiment and you know all the possible outcomes of that experiment, and out of those all possible outcomes, what are the different outcomes which are in your favor, for which you are looking? So those favorable divided by the total number of outcome, total number of possible outcome. So this ratio is nothing but the classical probability. So in this case, what we are assuming that all the events are equally likely. All the events are having equal chance of happening. For example, you must have seen the toss of a coin. If you toss a coin, so all of us know that either head will come or tail will come. So in advance, we are aware that there would be two outcomes. For example, we want to know what is the probability that head will appear. So out of those two events, one can appear at a time. So how many events are in your favor? So out of two, only one. So as per the definition of this classical probability, that favorable number or the outcome you are looking for divided by the total possible outcome. So this will give you the probability of happening. Similarly, you can calculate in any case. For example, we have toss of a die. So all of us know that there are 6 spaces in dice. If I ask you that what is the probability that one will appear? So because 6 cases are there, any one can appear. So you are talking about 1. So your favorable case is 1 and total number of cases are 6. So your probability 1 by 6. So in this case again, we are assuming that all the events are equally likely, equal probability of happening of any of the event. Now when we come to this relative frequency probability, now structure wise if you look at this particular method, so again the structure is same. the favorable cases divided by total number of cases. But here, what do? We compute this particular probability after performing the experiment, or the number of time an event occur divided by the number of trials. Because suppose if we say what is the probability that a ceiling fan will fall down, so we cannot just calculate the number of possibilities and out of that one is of our favor, then simply use a classical method. So it not make any sense. It will not give you the right answer. So in these type of cases, because these two events are not equally likely, lot of efforts are made that this particular ceiling fan should not fall down. So these are not unbiased. So biasness is there toward one side. So you cannot use directly classical method of probability. So we have to see that how many fans are there in that area or that particular building. Out of those, how many had the problem? So that number of problem divided by total installed fans in that area can give you the result in this case. So this method is relative frequency probability. So then it comes to subjective probability. In subjective probability, there is person's intuition or reasoning also. Sometimes data is not available. So in that case, we have to rely on the judgment of expert. So it depends that what is the experience of person and what information is having or she is having. So on the basis of that, we can assign some number and that would be the probability or chances of happening of that particular thing. So generally we use this in new product introduction, sometime site selection, sometime it could be supporting events. So these are three methods of calculating the probability: classical, relative frequency, subjective. Now the structure of probability. So there are some terminology which we use. There are something which is required to understand to solve the problem where probability is involved. For example, experiment. What is experiment? Experiment is a process that produces an outcome. Event, an outcome of experiment. Suppose if we toss a die, so tossing a die would be your experiment, but the outcome, suppose 1 appears or 2 appears or any number appears, so that would be your event. So elementary event that cannot be decomposed or broken down into other events. Like in case of a single die, 6 phases are there, so further we cannot divide these events. Then sample space, the complete roster, listing of all elementary events for an experiment. So that could be, suppose we toss a die twice, so what could be the different outcome? There could be 1 on first die, 1 on another die. There could be 1 on first and 2 on second die. So similarly, if you look at, so you will have list of outcomes. So that complete roster is nothing but your sample space. Then trial, one repetition of the process. So once you repeat this process, so that one repetition is nothing but a trial. Like you roll the dice, so that can be considered as trial. One concept we have already seen, equally likely, when all the events have equal chances of happening. Another things comes mutually exclusive event. These are the event where occurrence of one preclude the occurrence of other. These events have no intersection. Once one event has happened, there is no chance for other. Nothing overlapping, mutually exclusive. Then it comes to independent events. Occurrence or non-occurrence of one has no effect on the occurrence of other. So when we talk about independent or dependent, so naturally we must be talking about two events at least. So if one event happens, is it going to influence the happening of second event or not? So it depends upon that. Then we have collectively exhaustive events. So listing of all possible elementary event for an experiment. And then complementary event, for example, when we were talking about some number in case of when we toss a dice. So for example, you are asking for even number, so all the odd number would be the complementary event. So as we already discussed, sample space, the set of all elementary event for an experiment, method for describing a sample space. It could be roster or listing simply. Tree diagram, set builder form, Venn diagram. So whenever these will come, so we will discuss them in detail. Now, for example, we have this kind of data where different families and what are the number of children in that particular household, how many automobile. For example, we randomly select without replacement two families from the resident of this tiny town. So now you can see how many events would be there in this particular thing. So out of these 4, we have to select 2 at a time. So it could be AB, AC and so on up to DC, right? So each ordered pair in this sample is an elementary event. For example, this last one is. Now we have notation that S is equal to, within bracket, if we mention xy, so x is the family selected on first row and y is the family selected on second row. So this is another notation like we did in first case, we mention D or C. So if in general, if we mention like this, so this could be the notation for all. We need not to list all the outcomes, but simply just writing this thing and just mention that what exactly x or y is. So this concise description of large sample space can be done. So this is another form. Then there are some concept like union of two sets. For example, we have first set where 1, 4, 7, 9 are the elements, and then in second set 2, 3, 4, 5, 6. If we have to find out the union, so union is nothing but without repetition, all the entries which are there in either of the set. So here we can see 1, 2, 3, 4, 5, 6, 7, 9. So if we include only these entries without repetition, although we can see that 4 is twice in this, in both the cases, so we have just mentioned it once in this. So union is joining all the element without repetition. It could be in alphanumeric, alphabet, text, like in C set we have IBM, DEC, Apple, and in F set we have apple, grape, lime. So union of C and F, C union F would be without repetition. So in both the cases we have this apple, but in union we will mention it once. And in terms of Venn diagram, if you want to present it, so whatever is overlapping area, so we will be counting that once. Now it comes to intersection of the set. So intersection is nothing but whatever is the common between two sets. So for example, in the similar set which we have already seen, the common is only this number 4. So intersection is nothing but the set of one entry which is just 4. And similarly, in a second case, if you have to calculate intersection, so whatever is common between these two sets, that can be written as a set of single entry. Now, when we talk about mutually exclusive event within no common outcome, occurrences of one event preclude the occurrence of other event. So, if this is the inverse and two sets are lying in this universe, so you can see there is nothing common. So, nothing common means if you take intersection of these, nothing common, so that intersection would be 0 or empty set. So, there is nothing common between these two. Then independent event. So, independent events, as already said, at least we are talking about two events. So, occurrence of one event does not affect the occurrence or non-occurrence of other event. So, that is independent. But if there is some influence, so these are dependent. So, then conditional probability of x given y is equal to the marginal probability of x. So, we will see that how do we calculate all this. But suppose if we have this probability of x when some y is already happened. So, we write it like x given y. So, if it is equal to x and suppose if it is some event y, happening of event y when x is already happened equal to y. So, that means these are independent. So, these are not going to influence with the happening of other event which is already happened. So, this kind of situation means it is independent event. Collectively exhaustive. Contain all elementary events of an experiment. So, sample space with 3 collectively exhaustive, or in case of suppose we toss a die, so all the 6 element or 6 number would be the all elementary event in that particular case, and we will call it collectively exhaustive events. Then there are certain things which we must know, that the probability of whole sample space is equal to 1, and if we have to suppose calculate any complementary event probability, so 1 minus whatever is the main event, so that can be calculated. Like if this particular diagram is considered as a universe and there is one event A, so complementary would be the total probability which is equal to 1. So, 1 minus the probability of this particular event can be calculated. Okay, so now when we talk about counting the possibilities, so you must have seen this rule many times when you were doing some calculation in schools also. So, MN rule. So, nothing new, but okay, let's see what we do in MN rule. Then sampling from a population with replacement or without replacement. So, in both the cases, how do we do it? So, let's see. If an operation can be done in m ways and second operation can be done in n ways, then there are mn ways for the two operations to occur in order. For example, a cafeteria offers 5 salad, 4 meat, 8 vegetables, 3 breads, 4 dessert and 3 drinks. A meal is 2 serving of vegetable which may be identical. How many meals are available? So, simply you multiply this number. So, these number of meals may be available in this case. And when we talk about without replacement, so you must have studied this combination formula. So, we can calculate the sampling from a population without replacement by using, for example, we have population of size n and we want to take a sample of size small n. So, how many sample can be taken? So, that is NCN, and this n factorial is, how do we calculate this factorial? For example, we have 3 factorial. So, multiplication of all natural number, right? So, 3 into 2 into 1, there would not be 0. in any case, don't go for the multiplication of 0, otherwise everything would be 0. So, in case of combination, for example, a tray contains 1000 individual tax return. If 3 returns are randomly selected without replacement from the tray, how many possible samples are there? So, in this case, your n is 1000 and small n, or if you are writing NCR, so that R is 3. So, NCR or NCN, so that 1000 factorial, 3 factorial and 1000 minus 3 factorial. So, sometime when you are calculating all these, so you need not to multiply all 1000 into 999 and so on, right. So, whatever is required, suppose in denominator you are having this minus 3, so you have to just open this particular factorial up to this number and rest will be cancelled out and you can calculate the value easily. Okay, so there is another example. For example, suppose small law firm has 16 employees and 3 are to be selected randomly to represent the company at annual meeting of the American Bar Association. How many different combination of lawyer could be sent to the meeting? So here again we have to identify what is our population. So 16 employees, 16 is your capital N, then small n is how many we want to select there, 3. So NC 3, 16C3, so accordingly we can calculate. Now we will be using 4 types of probability. Now what are those 4 types? Marginal, union, joint, conditional. So in marginal, the probability of single event. In union, there would be joint probability, there would be the probability either this first event or second event. So we combined them and notation wise we can write or we can put this symbol here, and you will see whenever some overlapping part is there, so just using that particular part, or we have seen in last example that if you are having 2 sets, so whatever is common, so that will be considered once, but in case of intersection another thing is there, so whatever is the common, so only that will be considered, so that is your joint probability. And in case of independent or dependent, if suppose 2 events are there, first is already happened, so what is the probability of second? So we will see that whether the probability of first event is going to influence the probability of happening of second event. So if this comes under this conditional probability. So now when we uses this general law of addition, so for example, if we have to find out union of 2 events, so generally we use this particular formula, probability of x plus probability of y minus probability of x intersection y. So what is this intersection? When we talk about this inverse, in this inverse we have these 2 events. So you can see these 2 events are overlapping. So when we talk about probability A union B or probability X union B, so we are talking about this region without repetition. So here you can see when I am talking about probability of X, so I have covered this particular. When I am talking about probability of Y, second part is covered. So this part is something which is being counted twice. So we have to reduce it or we have to subtract it once. So we will get our probability of X union Y. Similarly, for example, if the probability of N is 0.7 and the probability of S is 0.67, so there is something which is common between these, right? So we need to reduce that and we will get the probability of this N union S. It is always better if you convert this statement or the problem into the matrix, probability matrix. So you can easily calculate all kind of probability, whatever 4 type we have discussed in this case. So right now, suppose this probability matrix, whether increased storage space versus noise reduction is given in this way. All the probabilities are calculated here. So simply in this question, if I have to calculate union of this one, so I will calculate the probability of N. So how to calculate probability of n? Like this, n means noise reduction, s is storage, increase in storage space. So n means this noise reduction, s this complete yes total. So this total 0.7 is the probability of noise reduction. If there is no noise reduction, it is 0.3. Similarly, in case of storage space, increased storage space, yes, the total probability of increased storage space, we will use this thing, and in case of no increase in storage space, so 0.33. So similarly, we can see that once we know that laws of addition, so we can calculate and we can identify this number from the matrix and easily can be calculated. Now, for example, if a worker is randomly selected from the company described in demonstration, this problem below, what is the probability that a worker is either technical or clerical? So what we will be doing, instead of this managerial, professional, technical, just we will use MPTC. So if suppose this information is there, sometimes this information is not converted into tabular form, so we have to convert this first into tabular form. So then we can calculate anything from this particular table. Now see, question is, what is the probability that worker is either professional or clerical? So now if we have to calculate, first there are two events, one is professional, one is clerical. So what is the probability that person is professional? So just we need to see the total of this professional. So all the professional, how many professional are there? This 44. And if we have to find out clerical, so how many clericals are there? 31. So you can see if both the events are either row wise or column wise, so there would be nothing common between them. But suppose if some event is like here male or managerial, so male is this column wise, then managerial is this 11, male is 100, so there is something which is common, so then we need to reduce. Otherwise, if both the events are row wise or column wise, so nothing is common in that case. So now professional versus then again this situation is described. For example, new question is technical versus clerical. So we will see the total number of technical, this 69. What is the probability that randomly selected person would be a technical person? 69 divided by the total number of person. What is the probability that randomly selected person would be a clerical? So clerical, total clerical number is 31. So 31 by 155. So then what is the probability that randomly selected person is technical or clerical? So or clerical means it is a case of union, and because nothing common between them, so simply we have added. If suppose there is something common, so that we need to reduce. So in this case, because technical, clerical in a one direction only, so nothing common, so simply we added the probability and got the result. Similarly, you can see in the case of that professional and clerical, so professional 44 by 155, then clerical total is 31 by 155. So this is a summarization of both the cases. Now it comes to the multiplication of two event. So when we do multiplication, for example, this thing, so formula says the probability of that first event into the probability of second event when first event is already happened, right? Or sometime, because either it is x intersection y or y intersection x, so doesn't matter. But if the probability of y comes first, then we have to look for the probability of x given that or the y is already happened. So for example, these kind of probabilities are, if these are given, so simply you multiply this, so then you can get the answer. But how to do it if suppose these probabilities are given in the table and this question is asked, so how to calculate, we will see that. But before that, you just see the law of multiplication. The intersection of two event is called the joint probability. Law of multiplication is used to find the joint probability. Then law of multiplication gives the probability that both events x and y will occur at the same time. So if we have to calculate, suppose sometime this conditional probability, so this same formula can be manipulated. Now if the probability matrix is constructed, as I already said, that first of all, if we convert the statement or that particular problem into probability matrix, then easily you can calculate all kind of probability. So here we are using it for finding joint probability. So now see, if we have to calculate whether married or this and supervisor, married and supervisor, so two events are there. So what we can do, the probability of M into the probability of S when M is already happened, probability of S when M is already happened. So this M is here some condition. So we will see that how to calculate. So probability of M, look at the first part. M is this married, yes. So total number of married. So how many total number? This one. Right now already probability is calculated. This is given in terms of fraction. So we can directly use this. So it is a probability matrix. Or suppose in earlier case there were numbers only. So we can convert those number into probability using that classical method. Favorable cases divided by total number of cases. So here what we have already probability matrix. So probability that a randomly selected person would be a married. So this is the total probability for married. So M is actually, probability of M is actually 0.5714. Then probability of supervisor given that person is married. Supervisor given that person is married. So now how to calculate this particular thing? Here you have to given that this one is married. When something is given, so that means you have to calculate the probability of whatever is asked, probability of this supervisor from this married only, if it is already given, right? Earlier this was the probability of married, so we can calculate like this. If suppose there is a probability of supervisor, you can simply go through like this, supervisor you can. Now what will happen, if you have to calculate what is the probability that person is supervisor provided he is married, so we have to calculate the probability of supervisor out of married only. So these two number, we need to have a ratio of these two number, right? So this 0.1143 divided by the total of this probability of the married. So because right now already probabilities are given, so we can just take a ratio of these two and you will get this number. So you multiply and you can find out this thing. Now see, when we are talking about just intersection, so you can here married and this supervisor, you can calculate the intersection. But suppose if you have to calculate this part, so how to calculate? Whatever is the married, given that it is married, so you will take this column only, and then whatever is the number, right, of supervisor, yes, so that divided by this. But now you using these values, then you calculated 0.1143. But you can directly see that in this matrix, if directly we go for this intersection cell, in case of joint probability, you can directly write this number as an answer for the problem. So means how much easy it makes you to calculate probability once probability matrix is there. So you can see the manual calculations, right? And then once it is converted into this particular table, the probability, so directly you can go for the intersection. So in future, whenever we have to use intersection, probability for intersection of events, so directly we will go for the intersection part of this particular probability. Then there are laws of conditional probability. If x and y are two events, the conditional probability of x occurring given that y is known or has occurred is expressed as a x probability of x given y. The conditional probability of x given y is the joint probability of x and y divided by the marginal probability of y. So you must have seen this formula earlier. Probability of x intersection y was nothing but probability of x into probability of x given y, right? So here suppose probability of y intersection x, that is nothing but the probability of y into probability of x given y. So that same formula is manipulated, and from the same relationship you can calculate that conditional. So now just changing their sides, you can calculate the conditional probability, right? You can calculate conditional probability if the joint probability and marginal probabilities are available, right? So you can see here also, this is nothing but the same formula. If you change the sides, so you will come to know what exactly the meaning of this particular relationship. So now if the joint probability and marginal probabilities are known, you can calculate conditional probability. Now conditional probability, suppose 70% of the respondent believe the noise reduction would improve and 56%. So first of all, it would be better if we convert this situation into matrix, then you can easily calculate. Otherwise, if suppose small problem is given, you can also calculate. Like here, you are given the marginal probability as well as joint probability. So you can calculate the probability if randomly selected person believes storage space would improve productivity, given that the person believes noise reduction improve productivity. So you can directly, because this time these are directly given, but suppose in the same situation if you convert this into a probability metric, so you can calculate the probability of other events also easily, right? So now recall the two events that are independent, where when the occurrence of one does not affect the probability of occurrence of other one, x and y are independent, conditional probability is equal to the marginal probability. So that can also be seen. For example, here we want to calculate for the probability of A provided G is already happened. So what is that actually? If you have joint probability of A and G, divide that with the marginal probability of G. So marginal probability means row wise total or column wise total or row wise total. If you look at, so these are nothing but the marginal probability. Suppose finance A, marginal probability 0.2, manufacturing B, marginal probability 0.35, communication C, marginal probability 0.37. And if you look at the joint probability, joint, suppose northeast finance A, joint probability these are. So suppose we want to calculate the probability of A given G. So what we will be doing, joint probability of A intersection G, which is 4.07, then marginal probability of G, which is 0.21. So it can be, and if suppose these are A given G and probability of A are equal, so then these are independent. So in this case we can see the probability of A, which is actually 0.28, both are not equal, right? So that means when x and y are independent, the conditional probability is equal to the marginal probability, but this is not the case here. So that means these are dependent. Now the very important application of probability, which is actually known as a revision of probabilities, given by Bayes, so also known as Bayes rule. So allow for reversing the order of conditioning. Till now, what exactly we have done, that event has to happen and we were calculating probability in advance, that what are the chances that this can happen. So right now, what is the change in this situation? Event is already happened. So now we want to know what is the probability that whatever this event has happened has come from, or the source of this particular is this one. So means we are going in reverse direction, or sometime adding some new situation, we are revising the probability of that existing events, right? So how to revise that, or how to calculate this? So we will see one example where we can use it. In Bayes rule, we will use conditional probability. So the denominator is actually the collective exhaustive listing of mutually exclusive outcome of y, and denominator is a weight average of conditional probability with the weights being the prior probability of a corresponding event. So when you will see the example, you will find it very easy. For example, we have one situation: a particular type of printer ribbon is produced by only two companies, Aloma and Ribbon Company and South Jersey Products. So suppose Alama produces 65% of the ribbon and another company produces 35%. And it is also noted that 8% of the ribbons produced by Alama are defective and 12% of the South Jersey ribbons are defective, right? So a customer purchases a new ribbon. What is the probability that this first company, Alamo, produces the ribbon? Or it could be the other way also, that what is the probability that South Jersey produces the ribbon? So what we will be doing, first of all, probability that any ribbon is produced by Aloma. So that is already given here, 65%. Now the probability that ribbon is produced by South Jersey, so that is also given 35%. Now the probability that defective produced by Aloma, right, or defective produced by another company. So given that that's defective produced by this first company and probability of defective produced by second company. So if these are given, so using Bayes rule, what we will be doing, so we have two cases right now. One is production by this first company and defective produced by first company, production by second company and defective produced by second company. So these are two cases, so two exhaustive cases. So these will make your denominator, both the cases: first company, defective produced by first company; second company, defective produced by second company. And whatever probability you want to calculate, suppose some customer purchases this particular ribbon, what is the probability that this is produced by first company, Aloma? So it is, now in a numerator we will put the event which is related to first company. If suppose question is what is the probability that South Jersey is producing whatever defective has occurred, so South Jersey has produced, so in numerator we will put the values which are related to South Jersey, and in the denominator both of them. So in this way you can calculate this reverse probability. So this can also be seen or understood easily if we use this tree diagram. For example, we had two cases: either it is produced by this company A or ribbon is produced by SJ, right? So what is the probability that production of the ribbon through first company, that is 0.65, and production by the second company 0.35. It could be defective or it could be non-defective or acceptable. If it is defective, what are the chances? 8%. Then whatever acceptable chances, 0.9. If it is defective from the second, so what are the chances? 12. And what are the chances that it can be accepted? 0.88. So now if suppose we have to calculate the probability that second company has produced that defective, so whatever is the, see, this into this, multiply these two, you will get this number. So South Jersey and defective. So these are actually your exhaustive number of cases. So addition of these is nothing but your denominator. So whatever, suppose right now SJ, we have to find out the probability that it is produced by second company. So we will put this second number in the numerator. If suppose question is that this first company has produced, so we will put this number as a numerator and you will get the probability accordingly. So quite easy concept and easy to solve once you understood properly. So whatever methods is comfortable, right, suitable to you, you just use any of them. So this is what we wanted to discuss in this particular session related to probability. So I hope that basic concepts of the probabilities, some of the laws, different types, and this reverse probability, if not completely clear, so at least you have some idea about these probabilities. So once you will be there in live session, so we will be doing all the calculation manually as well as using through Excel. So, and I'm very hopeful that you will enjoy that learning, or you have also enjoyed this session what we conducted today. So thank you. Thank you.